So let's apply the rules we've learned so far from the previous video to a few more molecules here. Here, this molecule here has a hydrogen, carbon, and nitrogen. So this would be called hydrocyanic acid. But anyway, you don't need to know the name right now. Let's just figure out what the Lewis structure of this molecule is, HCN. So we've got an H and a C and an N. Hydrogen, remember the first rule is figure out how many total valence electrons there are. So hydrogen has 1, carbon is 4, nitrogen is 5. How did I know that? Because of the periodic table. You look and see where they are in the periodic table, and you can figure out your valence electrons that we talked about from that. Okay, so now we add all this up, and you've got 10 total valence electrons. Okay, who's going to be in the middle? Remember, hydrogen is never in the middle, never a central atom. Carbon needs 4 electrons to fulfill the octet. Nitrogen needs 3 electrons to fulfill the octet. So carbon needs more. Let's put carbon in the middle. So we're going to put a carbon in the middle, a nitrogen on one side, hydrogen on the other. Again, it does not matter where you put everything. Just right now what matters is the central atom. Okay, so we draw lines between the central atom and the peripheral atoms. How many electrons did we use up to create these 2 bonds? We used 2, 4, 4 electrons. So we subtract the bonding electrons from the total. 10 minus 4 is 6. You have 6 electrons remaining. Remember what the rule is. You distribute the remaining electrons in pairs around the peripheral atoms so that the peripheral atoms have an octet. And then if anything's left over, you put it on the central atom. Okay, we already know that hydrogen is fine like this. It's got 2 valence electrons. It doesn't need any more. So leave hydrogen alone. These 6 electrons are going to go right here. 1, 2, 3, 4, 5, 6. Peripheral atoms get the electrons first. Okay, great. Nitrogen's happy, hydrogen's happy, but carbon is far from happy. So how do we make carbon happy? Remember the rule I gave you at the end of the last video? The only way to do that, you can't just create electrons and just dump them in here. The only way to do that is to we're going to need to take 2 pairs from the nitrogen, because right now carbon's got 2 4 electrons around it. It needs 4 more electrons, so it needs 2 more pairs of electrons to be shared. So we're going to take this pair and bring them over to create some bonds. So when we do that, you end up having a triple bond. Notice what I did. I erased this and erased this. So now this nitrogen has this non-bonding and these 3 bonding. So this is perfect. This has 8, 8, 2. Every atom in this molecule has an octet. It has 1, 2, 3, 4 bonding pairs, 1 non-bonding pair. Sometimes the non-bonding pair, we call them lone pairs. Okay, so there's 1 lone pair of electrons and 4 bonding pairs. Okay, so that's this one. So we're done with this one. SO2 is the next one, sulfur dioxide. So let's do that. All right, it's a little tricky because sulfur and oxygen both need the exact same number of electrons to fulfill the octet. Sulfur has 6 valence electrons, oxygen has 6 valence electrons, but I have 2 of them, so that's 12, total 18 electrons. Okay, we have 18 total. The next rule says decide who's the central atom. Remember how I told you you choose the one that needs the most electrons to fulfill the octet? Well, if they both need the same number of electrons, then which one do we choose? Well, in a later video, I'm going to talk about electronegativity. Sulfur and oxygen are in the same group, but oxygen is more electronegative than sulfur. So we always choose the one that is less electronegative for the central atom. So I'm going to choose the sulfur in the middle. So when we're going to study electronegativity, you're going to learn that electronegativity increases as you go up a group. So the rule is if they're in the same group, put the one that is heavier, the one that's lower in the group, the one that is less electronegative in the middle. So we're going to put the sulfur in the middle, and an oxygen on one side and an oxygen on the other, and we're going to draw lines between the central atom and the two peripheral atoms. Okay, so how many electrons did we just use up to make the bonds, the bonding? 2, 4, okay, 14 remaining. Where do I distribute those 14 remaining electrons? Around the periphery. And then anything left over, you put on the central atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I still have 13, 14. Remember what the rule said, 13, 14? You dump it on the central atom. Okay, this oxygen has 8, this oxygen has 8. Take a look at this sulfur, 2, 4, 6. It doesn't have enough electrons. What's the only thing you can do when the central atom doesn't have enough electrons? You need to take a pair from the peripheral atoms. So it doesn't matter which one you take it from. This is a concept called resonance. When you are creating a double bond and the peripheral atoms are all identical, you sometimes can take it from this side, sometimes from this side. This is the movement of electrons. It does not matter. And it's called resonance. So I just erased a pair. Here we go. So now this oxygen's got 2, 4, 6, 8. This oxygen's got 2, 4, 6, 8. This sulfur now has 1, 2, 4, 6, 8. Octet rule fulfilled. You have 3 bonding pairs and 1, 2, 3, 4, 5, 6 non-bonding pairs, or 6 lone pairs. Okay? All right, good. And then the last one we'll do on this chart here is a polyatomic ion. And I didn't teach you guys about this yet, but I'm about to right now. You can do Lewis structures of polyatomic ions, because a polyatomic ion is just a bunch of atoms that are covalently bonded together. So you can do the Lewis structure using all the rules that we just covered, but you have to account for the charge. So when we're adding up the total number of valence electrons, we add in the charge also. If it's a -1, you add in 1 electron to the total. If it's -2, you add in 2 electrons to the total. If it's -3, you add in 3 electrons to the total. Well, what if it's +1, like with ammonium? You subtract 1 electron, okay, from the total. All right, so this is the nitrate polyatomic ion. We have a nitrogen and we have 3 oxygens. Nitrogen's valence electron, 5. Oxygen's valence electron, 6. But I have 3 of them, so that's 6 times 3 is 18. Plus 5, you end up with 23. Okay, what do we do with that 1 electron? You add it into the total, okay? Don't forget that. Anytime you're doing the Lewis structure of a polyatomic ion, you have to add in the charge into the total number of valence electrons. So this now is 24 total. Okay, so now the same rules apply. Who's going to be in the middle? Nitrogen needs more electrons to fulfill octet. Let's put the nitrogen in the middle. How many oxygens do I put around it? We have 3 oxygens. So here's an oxygen, oxygen, oxygen. Let's draw lines from the central atom to the 3 peripheral atoms. Okay, how many electrons did I just use up? I used up 2, 4, 6. Okay. All right, 24 minus 6 is 18 electrons. So I have 18 electrons to distribute. Where do they go? Remember, they always go on the peripheral atoms first, so that every peripheral atom gets its octet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm done. All the peripheral atoms have an octet. Nitrogen doesn't have an octet. What do we do? The only thing you can do, according to these rules, is to take a pair from any one of the peripheral atoms. Now, don't put crazy amount of double, triple bonds here. You only create these double bonds or triple bonds if you absolutely have to. And here you have to. But the typical student wants to like create tons of multiple bonds. Don't do that. Just the bare minimum. So I'm going to take this pair. That's it. I'm only taking one pair. I'm going to remove it from here, and I'm going to put it right here. So it's a bonding pair. So instead of being a lone pair, now it's a bonding pair. So this over here, I'm going to put brackets around it and show its negative charge. That is the Lewis structure of the nitrate polyatomic ion. Technically speaking, I'm going to erase these over here. You can have a nitrate looking like this. Or a nitrate looking like this. This concept where your double bond can move between one identical peripheral atom and another, this is a topic for those of you moving on into higher level chemistries called resonance. It just resonates from here to here to here. All three of them are correct. And sometimes they'll just do an arrow saying, okay, this one goes to this can go to this. They all exist. Okay? Good. So I think we've covered different scenarios for Lewis structures. The next videos, I think we can move on and talk about, or maybe we should do another, maybe we'll do one more polyatomic ion, and then we'll move on to the VSEPR theory, which will tell you about the shape of molecules, and we'll wrap up as much as we can. Maybe a few more videos and we'll be all set.